Good morning, dear students. Welcome back again with a new session of Standard 9, Chapter 5 Acid, Bases, and Salts. Now, this lesson will be explained in very short, and therefore, a humble request to all my dear students, those who are listening to this video, please be with your textbook so that the concept could be understood in detail with the help of examples. Let's begin with the lesson. A scientist named Arrhenius put forth a theory of acid and bases in 1887. This theory gives a definition of acids and bases. So, what is an acid? An acid is a substance which, on dissolving in water, gives rise to H plus ions as the newly cation. All positive ions are called as cations. A base is a substance which, on dissolving in water, gives OH minus ion as the anion. All negative ions are called as anion. The strong acid dissociates completely on dissolving in water, and the resulting aqueous solution contains H plus ions and concerned acid radicals. A few examples of strong acids are HCl. When it is dissolved in water, it dissociates to form H plus and Cl minus. Similarly, HBr, when dissociates to water, forms H plus and Br minus. In the same way, nitric acid, when it dissociates in water, gets converted into H plus ions, cations, and NO3 minus anions. Weak acid does not dissociate completely as dissolving in water, and the resulting aqueous solution contains H plus ion and the concerned acid radical in small quantities. There, acidic radical in more quantities. Here, acidic radicals in small quantities. Examples of weak acids are acetic acid and carbonic acid. CH3COH, when dissolved in water, forms CH3CO minus and H plus. Similarly, carbonic acid H2CO3, when dissolved in water, forms 2H plus ions and CO3 2 minus ions. The strong base dissociates almost completely on dissolving in water, and the resulting aqueous solution contains mainly OH minus ions and the concerned basic radicals. Examples of strong base are NaOH, that is sodium hydroxide, KOH, that is potassium hydroxide, and Na2O, that is sodium oxide. Weak base does not dissociate completely on dissolving in water, and the resulting aqueous solution contains small proportion of OH minus ions and the concerned basic radicals. NH4OH, that is ammonium hydroxide, is an example of weak base. The bases which are strongly soluble in water are called as alkali. For example, sodium hydroxide, potassium hydroxide, ammonia. The number of H plus ion obtained by dissociation of one molecule of an acid is called basicity of an acid. Number of OH minus ions obtained by dissociation of one molecule of base is called as acidity of base. Danish scientist Sorensen introduced a scale expressing H plus ion concentration, which is called a pH scale. Now, what is the importance of this pH scale? pH scale is found to be very useful in chemical and biochemical processes. See how it is useful and how it measures. See, it starts from 0.0 to 14, 0.0 to 6.9. We can call it as acids. Smaller the number, greater is the acidity. Similarly, from 7.1 to 14, smaller the number, weaker is the base, and bigger the number, stronger is the acid. You can see the examples here. 1 molar HCl strong acid 0.0 pH. Gastric juice 1.0 strong acid. Lemon juice 2.5 strong acid 2.5 pH. Vinegar 3.0 pH. Again, it is a strong acid. Now, from here, the acidity goes on decreasing. We call it as weak acid. Tomato juice 4.1. Then black coffee 5.0, then acid rain 5.6, urine 6, rain milk 6.5, pure water or sugar solution is neutral, neither acid nor basic. And blood is 7.4 pH. Solution of baking soda 8.5, which is weak base. Toothpaste 9.5, weak base. Then milk of magnesia, weak base. But here from 11, 12, 13, 14, there is strong base, lime water and sodium hydroxide of 1 molar. Very strong base. The pH scale extends from 0 to 14. The pH of an acidic solution is less than 7 and that of basic solution is more than 7. The pH indicates the neutral. pH 7 indicates neutral solution. A universal indicator is made by mixing several synthetic indicators in specific proportion. The pH of the solution can be determined by using universal indicator solution or the pH paper made from it. In neutralization reaction, the acid reacts with base to form salt and water. Salts are classified into acidic, basic and neutral salts. An acidic salt is formed by neutralization reaction between a strong acid and a weak base. The pH of acidic salt is less than 7. The basic salt is formed by neutralization reaction between a strong base and a weak acid. The pH of basic salt is more than 7. The crystalline substances indicate water of crystallization. Electrons conduct electricity through electrical wires and the ions conduct electricity through liquid or solution. The electrode connected to the negative terminal of a battery by means of conducting wire is called as cathode. Negative terminal cathode, positive terminal anode, and the electrode connected to the positive terminal of a battery is called as anode. Electrolysis. Electro means electricity. Lysis means splitting. So splitting with the help of electricity. In electrolysis, decomposition of the soluble in the solution takes place due to the electric current. Two reactions occur in the process of electrolysis: a cathode reaction and the anode reaction. Substances which undergo dissociation to a greater extent in the liquid state or a solution are called as electrolytes. So where electric current can pass through a solution, we call it as electrolytes. Where electric current cannot pass through a solution, we call it as non-electrolytes. Salts, strong acids and strong bases are called electrolytes because through which electricity can easily pass. Pure water is a bad conductor of electricity, so it is non-electrolytes, electricity cannot pass through it. So here, in short, we have completed this whole topic of this lesson. That's all for today. The remaining part of this subject, we can discuss it in the next video. Till then, have a great day.